If I have a quotient of powers, I can find the simplified version by considering the difference in the exponents. If I, for example, had 5 factors of x, and I was dividing that by 3 factors of x, using expanded form, I could write out my 5 factors of x over my 3 factors of x. And I can see that 3 factors of x from the numerator will join with 3 factors of x in the denominator and create this giant one. The difference is evident in the numerator, and that the fact that I have 2 additional factors of x left up there. So this becomes x to the second power over 1, or just x to the second power. And I can see that using the rule for dividing, same bases with exponents. So this becomes x to the 5 minus 3, which is x to the second power. I am not limited to a single variable, and I can also have some numerical values as well. So let's consider x to the third times y to the 7th over x y to the 5th. Again, using expanded notation, I have 3 factors of x in the numerator and 7 factors of y also in the numerator. In my denominator, I have a single factor of x and 5 factors of y. There is a 1 when I grab a single factor of x from both the numerator and denominator and 5 factors of y, 1, 2, 3, 4, 5, from the denominator. The answer I'm left with is 2 factors of x and 2 factors of y, or x squared times y squared. And again, this is an inefficient way to write this out, so I would write this as x to the 3 minus 1 times y to the 7 minus 5, x to the second times y to the second. So one of the problems that I've noticed over the years is that we get used to seeing the bases are the same and we do the subtraction, and all of a sudden some weird things start to happen. So for example, let's say that I have 16x to the 10th, and I'm dividing that by 20x to the 4th. Well, I understand that in terms of x, my answer is going to have x to the 10 minus 4 power, which is x to the 6th power. But I see students that will start to do this subtraction and take 16 minus 20 and write the number -4 in front of here. Well, it's not -4, right? This is a fraction at 16/20ths. And if I want to think about this, I would simplify this fraction. The number 16 I could express as 4 times 4, and the number 20 I could express as 4 times 5. I can see that I have a giant 1 in the form of 4 over 4, and I'm left with 4 in the numerator and a 5 in the denominator. So my answer would be 4 times x to the 6th power, those are the two things that were in my numerator, divided by 4. My point is, when you see a fraction, realize this is a fraction and this is a division problem, and you can often reduce fractions by writing them in factored form. Just another quick example of that. If I have 12 divided by 36, the factored form of 12 is 2, 2, 3. That's 2 factors of 2 and a single factor of 3. 2, 2, 3. 4 times 3 is 12. The number 36, I know is 6 times 6. If I was to think about it like that, that means that I have 2 factors of 2, because there's a 2 times a 3, and another 2 times 3, and 2 factors of 3. So I can write this as 2, 2, and then 3, and then 3. Well, 4 times 9 is 36, or 6 times 6 is 36. The point is that 2233 is the number 36. And I can clearly see that I have a giant 1 in the form of 2 factors of 2 and a factor of 3, or 12. In this case, I'm left with just the number 1 in the numerator. Remember, it's a giant 1. And the number 3 in my denominator.